We have a cosine law. Would it much surprise you if I told you that there is also something called a sine law? All right, well, there is. So let's review. Don't write this down yet, but let's just quickly review what the cosine law tells us. Remember that this is B, this is C, and this is side A, right? The opposite of the angle is the side. The cosine law tells us that if we have two sides and an angle, in other words, side, angle, side, or we have all three sides of a triangle, of a real triangle, and no angles, in other words, side, 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 that we can then go ahead and solve this triangle using the cosine law, which was, if you recall, either c squared equals a squared plus b squared minus 2ab cosine c, or an alternative form of it, if I'm looking for an angle, cosine c equals a squared plus b squared plus c squared over 2ab. Okay, that's the two forms of the cosine law, which will allow you to solve either a side angle side triangle or a side 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 triangle. All right, so how does the sine law work? Well, first we have to erase all this stuff. All right, so let us go back and relabel the sides. That is still side B. This is still little c, and this is still side A. And let us, again, just as we did with the cosine law, drop a vertical line that is right angles to the base from the apex point of the triangle. In this case, it's angle A. And similarly, let's label the height of the triangle like that. And let's just label that angle D. And that is an angle, remember. It's a flat angle of 180 degrees. It just doesn't look like a pointing angle like you see in the other parts of the triangle, but it's still an angle of 180. So we're going to label it as D. How do we do this? Well, let's take a look at here. Let's look at angle C. We know that sine C equals H over B. And if I wanted to rearrange that, I could say H equals B sine C, okay? Basic trig and basic algebra. Well, similarly, if I were looking at angle B, I could say sine B equals that same H, but over C. And rearranging it, of course, would give me H equals C sine B. So what? Well, if H equals B sine C and H also equals C sine B, then necessarily B sine C equals C sine B. It all flows naturally and logically, doesn't it? So this is interesting, but it doesn't really give us a formula that's very useful to us. So we're going to do one little trick here. We're going to divide both sides by BC. B times C. And when we do that, well, it's going to look like that. And when we simplify by dividing out, on the left side, we're going to get sine C over C equals, and then divide that out, sine B over B. And there's the basis of our sine law. Sine C over C equals sine B over B. Well, you might ask, what about sine A? How are we going to deal with that? Well, to get sine A, all you got to do is rearrange the angles and call that A and call that C, but that's not very satisfying. Extended the triangle like that and created a new height from angle C, you'd find out that you get the same relationship, sine A over A. Right? So there's a very simple sine law. What's it good for? It's good for when you don't have an SSS as a side-side-side triangle or a side-angle-side triangle. If you have something other than those two, then you can use this to solve. So to summarize, sine A over A equals sine B over B equals sine C over C. And if sine A over A equals sine B over B, then the converse is also true. A over sine A must equal B over sine B, which must equal C over sine C. If one is true, then the inverse relationships are also true. So what kind of triangles are these good for? Well, they're good for non-right angled triangles like that, where you have one angle and a side length, and perhaps another side length, and no angle. And the way to notice that the SIne law is the proper rule to use is that if you have these pairs, okay? So there's an angle side pair, an angle and its opposite side, and we want to figure out an angle or an opposite side given one of those two, right? So in this case, we have to figure out theta. So if you know an angle and its opposite side and one other side or angle, then you can use the SIne law. All right, let's try some examples. Solve the following triangle. Round the side lengths to the nearest tenth. Remember, we need an angle and its matching opposite side. Do we have that? Well, we need to solve the triangle. So let me call that x, and I'm going to call that y, x and y. You may notice that we have no side and angle pairs, right? The closest thing we have is this one here, okay? We have a side, but we have an unknown angle. Luckily, that angle is very easy to discern because it's equal to 180 minus 88 minus 61, which is to say 31 degrees. All right, so now we've got an angle and opposite side pair. Now we can figure out everything else. So let's do x first. We know that x over sine of 61 degrees is going to be equal to 1.8 over sine 31 degrees. In other words, when I cross multiply, I'm going to get x sine 31 degrees equals 1.8 sine 61 degrees. And if I want to isolate the x by dividing by sine 31, I would get x equals 1.85 times sine 61 degrees divided by sine 31 degrees. And now it's just a very simple matter of popping that into your calculator to give you the value 3.5. 3.5 kilometers, because that's our final answer. All right, well, let's do this angle. Let's do this pair right there now, 88 degrees and y. And once again, if we go y over sine 88 degrees, it's going to be equal to 1.8 over sine 31 degrees. And when you do your rearrangement magic here, you're going to get y equals to 1.8 sine 88 all divided by sine 31 degrees. And when you sort through that mess, you get 3.1 kilometers. Boom, there you go. Easy peasy. Nothing hard with that. The secret is in identifying those cross pairs, an angle with its opposite side. Let's do another. A ship at sea is sighted from 2 Coast Guard observation posts on shore. So I would imagine this is one observation post and this is another observation post. The angle between the line of sight between post A and the line between the two posts is 110 degrees. Okay, that puts A here. From post B, well, this must be the other post there. The angle is 30 degrees. If the two observation posts are 5 kilometers apart, we should be able to figure this out. We want to figure out X and we want to figure out Y. So the good news is that we do have a pair. If we can identify this angle as being 180 minus 30 minus 110, oh heck, let's just call it 40 because that's what it is. Then we have our first angle and opposite side pair. So we can say with conviction that sine of 40 degrees over 5 is going to give us all of those other relationships. For example, sine 110 over x and sine 30 over y. A little bit of rearranging says that 5 times sine 110 divided by sine 40 will equal x. And doing the other side, we'll find that y is going to be equal, because we're doing this side, right? So y is going to be equal to 5 sine 30 degrees divided by sine 40 degrees. All right. And because I'm in green, I'll do it first. When you plop that into your calculator, you should get 3.9 kilometers, and x should equal 7.3 kilometers. Easy peasy. This is almost easier than the cosine law, isn't it? One more example. So now this isn't so simple because we have to draw the triangle. And as I've said in the past, often drawing the diagram is sometimes the hardest part of the whole problem. And as soon as you have that good and down, then you should be able to figure things out. So I've got 64 degrees. I see that angle there. All right, so I'm just going to go ahead and draw a rough triangle here and see if I can't make any sense out of it. WFT. W is 64 degrees, so why don't I just arbitrarily label that as W, and there's 64 degrees, okay? Side W, okay, that's the opposite side here, is 25.2 centimeters, all right? T is, little t is 16.5 kilometers. Now, it really doesn't matter whether, I could put big T here and little t here, or I could put big T here and little t here, and I think that's what I'll do, just, for no good reason. All right. And that leaves us with F, and this is little f right there. All right. Determine the measure of angle F to the nearest degree. All right. Well, the good news is that I've got an angle and opposite side pair, so I know that sine 64 degrees over 25.2 is going to be a good little thing to do. But the problem is that I have neither big F nor little f, so I can't use that angle pair yet. But I think I can get there by looking at this angle and opposite side matching pair, because I know that sine of angle t, which is there, sine t over 16.5 will give me an equivalent relationship. What does this mean? It means that sine of angle t is going to be equal to 16.5 times sine 64 degrees, all divided by 25.2. And if sine t is equal to this mess, then angle t itself is going to be equal to the arc sine, or the sine inverse, or the sine -1 of 16.5 sine 64 degrees, all divided by 25.2. Basic trigonometry. And what does that give us? T is going to be 36 degrees rounded off to the nearest degree. All right, cool. But that's not my final answer. Knowing that this is 36 will help me understand that this angle here must be 80 degrees, because this is 180 minus 36 degrees minus 64 degrees equals 80 degrees. There's my answer, and there's your problem solved. Easy peasy.